Okay, number 1, we want to find x. So here you have to be careful because sometimes you're going to be given pictures like this. So let me show you real quick on the formula chart. So like when I look at this one, I see that I have 2 secants here, and I'm given the arc measure. But then also down here, we have 2 secants, but then here we're going to be finding the length of those whole secants. Okay, so you have to look and see, well, what you're looking for. So on number 1, we're looking for this one. We're trying to find x, we're given the 2 arc measures. So our formula is 1/2 times the major arc minus the minor arc. So if I put that in my calculator, oops, I get 34. Okay, number 2. So number 2, I'm given, again, 2 secants, but I have pieces like this. So now I'm going to do outside times whole equals outside times whole, and be extra careful here. So let's start with this one here. We have outside, which is 3, times the whole. So I have to add up these two. So 3 plus 5 is 8. So 3 times 8 equals outside times whole. So the outside here is 2 times the whole is 2 plus z. So I get 24 equals, on this side we're going to distribute, so 2 times 2 is 4. 4 plus 2z, subtract the 4, and divide by 2. So z equals 10. Okay, number 3, the circumference of a steering wheel of a car is 20 pi inches. What is the radius? So you're given the circumference formula here. So since they want the radius, let's use 2 pi r. So our formula is 2 pi r. But in this case, instead of giving us r, they're giving us circumference. So we're going to put 20 pi in. And we want to solve for r, so divide by 2 pi. You can put that in your calculator, but here the pi's cancel. 20 divided by 2 is 10. Number 4. So number 4, I have these segments. So I want to go to my pictures here, and I'm going to go to this bottom part. So I have this. I have intersecting segments inside a circle. So that's part times part equals part times part. So if we start with this one, I have 3 times x equals the other one, 5 times 7. So make sure you don't mix up and do like 3 times 5. It's the part of the what's this one and then the other part. So 3x equals 35. And then if we divide by 3, we can see they gave us 35 over 3 as an option. Number 5, find x. So if I go to my circle here, we're looking at arc angle measure and then an arc measure. That's an inscribed angle, so that's going to be this one right here. So the arc is 2 times the inscribed angle. So 2 times 72, 144. Number 6, find the radius of the circle. Okay, so the radius comes from this. Our circle formula has r squared right here. So I want to square root 100, which would be 10. Number 7, find x. Assume that segments appear tangent are tangent. So that means that if this appears tangent, it makes a right angle. So I can use Pythagorean theorem. Good old Pythagorean theorem never goes away. So 10 squared plus x squared equals 26 squared. So 100 plus x squared equals 676. Subtract 100. And square root. So the square root of 576 is 24. So that's what x is. Number 8. The radius of circle T is 8 meters. So let's draw a little circle here. There's circle T. So the radius is 8, and GTH, so we're going to go GTH, is 45. Now that's the measure of the angle, so this is 45 on the inside. They want us to find the length of GH. So this is this proportion one right here. Okay, so the length of the arc, that's what we're going to try and find. So let's go x over circumference. Remember, circumference is 2 pi r. Well, they gave us that the radius is 8, so if I put that in 2 pi 8 or 16 pi equals, on the right hand side we have the degree measure of the arc. Well, if this is 45, it's a central angle, then this measure of GH is 45. We're trying to find the length over the degree measure of the whole circle, which would be 360. So cross multiply. I'm going to do 45 times 16 pi in my calculator and then divide by 360. So the length of GH is 6.28. Okay, number 9. If the measure of angle X is 126, find measure Z. Opposite angles are supplementary, so just subtract from 180. 54. Find the center of the circle. So the center here, remember we have to change the sign. So if this is a positive 15, it's going to become a negative 15, that's our H. And then this is going to become a positive 20, that's our K. So negative 15, positive 20. Number 11, find the measure. So this one, the measure is just the arc measure of GH. So right here. So let's look and see what we have. This is 90 and this little one's 20. Well, I could add those, which is 110, and subtract from 180. Now, I'm subtracting from 180 because this EG is a diameter, which means this whole thing is 180. So I can find out what this piece is. So then this piece here is 70, and then vertical angles tell me that this is also 70. Number 12, find EF. So since we know that those pieces are tangent, we can use the hat theorem. If this is 2, then this is 2. And then this part here is 4, which means this part is 4. So then that means since the whole thing's 9, this is 5. And then the hat theorem tells us that this is 5. So EF would be 2 plus 5, so 7. Number 13, determine if CB is tangent to the circle if x equals 15. Okay, so to determine that it's tangent, we need to determine that this makes a right angle or a right triangle. So let's check Pythagorean theorem. So a squared plus b squared equals c squared. They gave us x is 15. So we'll go 12 squared plus 15 squared equals 20 squared. So in my calculator, I'm going to do that left side, 12 squared plus 15 squared. I got 369. And on the right side, I'm going to do 20 squared is 400. So it's a no because we got 369 does not equal 400. So no, and then let's check this. 12 squared plus 15 squared does not equal 20 squared. That one's kind of tricky, so make sure you just pay close attention to what's written here. Number 14, find the equation of a circle whose center is at -1, 5, and radius is 8. Okay, first thing, remember our equation, x minus h squared, y minus k squared equals r squared. You have to square the radius. So if the radius is 8 here, it can't be f and it can't be h. Then when you input those into the equation, x minus a -1 plus y minus a positive 5, it changes sign. So this becomes x plus 1 squared plus y minus 5 squared, which would be j. Number 15, find the measure of angle 6. Okay, so this one's a tricky one because it's a two-step process. So we're going to use this one right here. We're going to find this angle first by doing 1/2 times the two arcs added together. And I'm going to call this x, and then we're going to subtract from 180. So I'm going to do 1/2 times 50 plus 60, which gives me 55. So this here is 55. And then I'm going to subtract from 180 to get 125, which is what measure 6 would be. Okay, so two-step process there. First find the single angle, then subtract from 180. Number 16, find x. Okay, so they're giving us lengths of the secant. So segments that we have are here. So that's going to be this one, tangent squared equals outside times whole. So the tangent is x, so we're going to go tangent squared equals outside, which is the 2, times the whole, so 6 plus 2 is 8. So x squared equals 16, square root x equals 4. Number 17, find the equation of circle P. So two things we need to know. The center, which is at 0, 1, 2, 3. So the center is at 0, positive 3, and the radius is 1, 2, r equals 2. So remember, when we put it in the equation, we're going to square it, so it can't be b or c. And then when I put the center in, if I put 0 in, I'm going to just get x squared. So then make sure that this is opposite signs, so it has to be a. Okay, number 18, that's again our outside times whole equals outside times whole. So 5 times 5 plus y. There's the outside and then the whole equals 6 times 6 plus 8, which is 14. So distribute on the left side. And 14 times 6 is 84. Subtract 25 over. And divide by 5. So 59 over 5 is y. Number 19, find y if mn equals y plus 1. So down here we have y plus 1. Assume that segments appear tangent are tangent. Well, here we can just use the hat theorem. If this is 3, that means this is 3. So we can say y plus 1 equals 3. Subtract 1, so y equals 2. Number 20, in circle F, CFD is congruent to DFE. So these two are the same. BFA is 7x, and AFE is 5x plus 12. So we want to find the measure of arc DC. So this one's a little tricky. First thing I would do is, since BE is a diameter, this whole thing is 180. So if I add those two angles together, I can solve for x. So I get 12x plus 12 equals 180. Subtract 12 over and divide by 12. So x equals 14. Now if I want to find the measure of arc DC, I need to know what just this piece is. So if this whole thing is 7x, let's plug the 14 in there. 14 times 7 is 98. So this whole thing here is 98, which means that this whole thing is 98. So from here to here is 98, and since they're congruent, I can divide by 2 and I get 49. There's a lot going on in that problem, so you might want to try it on your own a couple times without looking and make sure that you can figure it out. Number 21, it says use circle D, name a tangent. So a tangent, remember, touches a circle at the outside on one point. So a tangent could be CE. Name a chord that is not a diameter. So that would be CB with a straight line across. And then name a secant. A secant goes through the circle and touches it twice, but this one goes through the circle, so I can put the arrows there. 22, find x. So this would be, we have a tangent and a secant. So this is going to be our formula, tangent squared equals outside times whole. So our tangent is 6, so 6 squared equals outside times the whole, 3 plus x. So 36 equals 9 plus 3x. Subtract the 9, so 27 equals 3x. And x equals 9. Number 23, find y. So this is our part times part equals part times part. So 3 times 9 equals 6 times y. 27 equals 6y. And divide by 6, and I got 4.5. 24, find the measure of angle 8. So this one is a tricky one, but this is still just an inscribed angle, and our inscribed angle is just 1/2 times that arc, which would be 110. Now, let's say, let's do 3. Let's say that in this case they gave us this one was 140. You can't do 1/2 times 140. You have to do 360 minus 140 to find this arc. And then from there, then you can do 1/2 times that arc. Okay, so just be careful. And the last one, number 25, graph the circle. So first thing, let's label the center. So the center's at, if this is a -3, it's going to be +3 and then -1. And the radius, remember, is the square root of this. So the radius would be 3. So we graph the center, 1, 2, 3, -1. And then since the radius is 3, we'll go 3 to the right, 3 up, 3 to the left, and 3 down, and draw your circle. And that's it. So good luck on your test tomorrow. I hope that it goes well, and hopefully this was helpful for you.